Hello everyone, today I would like to introduce you EMD again. So EMD, in my research, EMD is for underwater acoustic sources identification and classification, and particularly in they identify and classify for marine mammal species. And why? Why I want to do this? Because we do this for the purpose of protecting them. Because if when human activities on the over the ocean, so if we can identify and classify those kind of marine mammal species through the underwater sound sources, then we can avoid colliding with them and to protect them. So how to do this? This kind of sound identification in the water is same as sound identification in air condition, but I guess it's totally different. Processing signal in frequency domain is widely used in different kind of field like Fourier and wavelet transform, but for underwater acoustic sources, they cannot work effectively because of complicated underwater background noises like rain noise, ice cracking noise, or underwater blow at all. And what makes this worse is that some kind of noise like passing both engines from passing both engines can completely skew any spectral indexes. So that means we cannot process those kind of source, those kind of data in frequency domain. And we found EMD, uh, empirical mode decomposition. Is the EMD is an adaptive tool working in the time domain and can break down time domain signals into amplitude modulated and frequency modulated components. We call it IMFs. And the EMD do not need prior knowledges when processing any signals. And this is his big advantage. And EMD has been proved effective in processing underwater acoustic data. So Sager et al. In 2018 used the correlation coefficients of IMFs in the same site as an index to detect or extract components of desired signals from the mixed sound source. Next, they used a digit of IMFs with the first and second highest power to construct two-digit EMD identity for each sound source, and then use this two-digit EMD identity to classify and identify signals. So what's the problem? The problem is currently only one index developed from EMD technique, and it was used in the identifying and classifying marine mammal species. And we know that this index is the digit set of highest power of IMS. And even though this index have been proved works in the dataset with 35 waveforms, wave fields, and 8 sound source examples, when complicated underwater circumstances present and more sound sources in the detected data, its performance is maybe less optimistic. So in this paper, my goal is to improve on performance on current EMD technique. Uh, Tussley et al. estimated bird species richness by sampling data recorded under natural conditions. This is the above water, in the natural conditions, with all the attendant problems of unconstrained acoustic content, such as wind, rain, traffic, everything. They compared 14 acoustic indexes and showed that combination of indexes will lead to more efficient estimates of species richness than only use one index. So the hypothesis here is that we can use if we can combine multiple indexes in identification and classification, EMD techniques can also be more robust and elastic when used in various underwater situations than the case that only use one index. So next problem is, what indexes should I choose? The Mel frequency spectrum is a representation of the short-term power spectrum of a sound. So Mel frequency capture coefficients, we call it MFCCS, has been widely used as features in speech recognition tasks. And another index is cross-correlation. Cross-correlation feature is a measure of similarity of two variables or two sides of data, and have been often used in sound sources identification research. And thus, Wei et al. Established a deep natural network model by combining recurrent natural network with convolution on the natural network. So something, but their results show that using MFCCS as a feature of parameter can achieve efficient classification of underwater acoustic signals. And P. Mess et al. In 1996 used cross-correlation measurements to identify the spatial correlation of broadband noise sound sources. And Young et al. In 2013 used spatial cross-correlation of noise source imagining for underwater weak noise identification. And their simulation results show that the cross-correlation operation achieve additional SNR improvement and better resolution than conventional methods. Thus, in this paper, in my research, the indexes are going to be used the indexes are going to be used in this paper are, the first one is the digital set of AMS with highest power, and the second one is Mel frequency capture coefficients, and the third one is cross correlation coefficients. And testing simulation. How to test them? I want to use simulation. And first step is to model these sites with different number of sound source and simulate different underwater environments with different levels of noises. The second step is EMD processing, decomposing those sound sources into IMFs and testing proposed two new indexes in identification and classification process. The third step is using multi-indexes with EMD and comparing the processing result with the result of single index processing situation. So the testing metric is that if proposed indexes can identify the testing metric is that if we are looking for if the proposed indexes can identify desired sound signal in the mixed sound dataset without missing and mismatch. And this is the references. Okay, that's all. Thank you.